Section 14.1, Quadratic Equations, the Square Root Method. The objectives: solve quadratic equations by factoring, solve quadratic equations using the square root method, solve problems related to right triangles and the Pythagorean theorem. The zero factor property. If the product of two or more factors is zero, then at least one of the factors must be zero. That is, if a and b are real numbers and a times b is zero, then a equals zero, or b equals zero, or both. Quadratic equations are equations that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Solving quadratic equations by factoring. Step 1, add or subtract terms as necessary so that 0 is on one side of the equation and the equation is in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Step 2, factor completely. If there are any fractional coefficients, multiply each term by the least common denominator so that all coefficients will be integers. Step 3, set each non-constant factor equal to 0 and solve each linear equation for the unknown. Step 4, check each solution one at a time in the original equation. Example 1, solve the quadratic equation by factoring. X squared minus 15x equals negative 50. For our solution, the first thing we're going to do is set it equal to 0 by adding 50 to both sides. That gives us x squared minus 15x plus 50 equals 0. Then when we factor the left-hand side, we end up with x minus 5 times x minus 10 equals 0. Two things that multiply together to give me 50 and add to give me negative 15. Setting each linear factor equal to 0, I have x minus 5 equals 0, or x minus 10 equals 0. Adding 5 to both sides on the left gives me x equals 5. Adding 10 to both sides on the right gives me x equals 10. We're going to check both of those solutions to see if they work. Again, our original equation is x squared minus 15x equals negative 50. Plugging in 5, we have 5 squared minus 15 times 5. Does that equal negative 50? We get 5 squared is 25. Negative 15 times 5 is negative 75. Again, is that equaling negative 50? Yes, negative 50 equals negative 50, so the solution 5 checks. Plugging in 10, we have 10 squared minus 15 times 10. Does that equal negative 50? That gives us 10 squared is 100. Negative 15 times 10 is negative 150. Does that equal negative 50? And 100 minus 150 is negative 50, so negative 50 equals negative 50. In that case, both solutions checked. Example 2, solve the quadratic equation by factoring. 3x squared minus 24x equals negative 48. We're going to start by setting it equal to 0 by adding 48 to both sides. That gives us 3x squared minus 24x plus 48 equals 0. We're going to factor out our greatest common factor of 3. 3 times x squared minus 8x plus 16 equals 0. Now we're looking for two things that multiply together to give us 16, and when I add them together it gives me negative 8. That's going to become 3 times x minus 4, that quantity squared, equals 0. Setting that factor equal to 0, I have x minus 4 equals 0. Adding 4 to both sides, x is equal to 4. This solution is a double root. Checking that in my original equation of 3x squared minus 24x equals negative 48 gives me 3 times 4 squared minus 24 times 4. Does that equal negative 48? 3 times 4 squared is 3 times 16, which is 48. Minus 24 times 4 is 96. 48 minus 96 is negative 48, so negative 48 does equal negative 48, so this solution checks. Example 3, solve the quadratic equation by factoring. This time we have x squared plus 4 equals 0. For our solution here, we have already ended up with our equation set equal to 0. Note that x squared plus 4 is the sum of two squares and can be factored into the product of conjugates of complex numbers. X plus 2i times x minus 2i equals 0. When I set x plus 2i equal to 0 or x minus 2i equal to 0, I end up with x equals negative 2i on the left by subtracting 2i from both sides. Adding 2i to both sides on the right ends up giving me x equals positive 2i. Checking my solutions for x squared plus 4 equals 0. When I plug in negative 2i squared plus 4 equals 0, negative 2i squared is 4i squared plus 4. 4i squared is negative 4 plus 4, which does equal 0, so that solution checks. 2i squared plus 4 equals 0. 2i squared is 4i squared plus 4. 4i squared is negative 4 plus 4. Negative 4 plus 4 is 0, so 0 equals 0. Both of those solutions check. Square root property. If x squared equals c, then x is equal to plus or minus the square root of c. If x minus a, the quantity squared, is equal to c, then x minus a is equal to plus or minus the square root of c, or x is equal to a plus or minus the square root of c. Note, if c is negative, which means c is less than 0, then the solutions will be non-real. Solve by using the square root property. Y plus 4, that quantity squared, is equal to 8. For my solution, I'm going to make sure in this case that the squared term is isolated, which it is. And we'll notice that 8 is greater than 0, which means that we are going to end up with positive real solutions. So you take the square root of both sides. Y plus 4 is equal to plus or minus the square root of 8. Subtracting 4 from both sides, y is equal to negative 4 plus or minus 2 square root of 2. Example 5, solve by using the square root property. X squared equals negative 25. Note here that negative 25 is less than 0, so we're going to have imaginary roots for our solutions. The x squared term is isolated, so I'm going to take the square root of both sides. X equals plus or minus the square root of negative 25, which means x is equal to plus or minus 5i. The Pythagorean theorem, which shouldn't be new to us. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the two legs. C squared equals a squared plus b squared, where c is your hypotenuse, or the side opposite of the 90-degree angle, and a and b are your two legs. Example 6. If the hypotenuse of a right triangle is 15 centimeters long and one leg is 10 centimeters long, what is the length of the other leg? And we have a picture showing the triangle labeled. For our solution, we're going to use the Pythagorean theorem. A squared plus 10 squared equals 15 squared. So leg squared plus leg squared equals hypotenuse squared. A squared plus 100 equals 225. Subtracting 100 from both sides, a squared is equal to 125. Taking the square root of both sides, we get a is equal to the square root of 125. In this case, remember we're talking about length, so we would throw out the negative solution. Now we can simplify the square root of 125 into the square root of 25 times the square root of 5, which is 5 square root of 5, which is approximately 11.18 centimeters. So the other leg is 5 square root of 5 centimeters long, or approximately 11.18 centimeters long. The negative solution to the quadratic equation is not considered because length is not negative, which I mentioned earlier. Example 7. The diagonal of a rectangle is twice the width. The length of the rectangle is 6 feet. Find the width of the rectangle. So the diagonal of a rectangle creates a right triangle. So we know that the diagonal is the hypotenuse, which is 2x in this case. One of our legs is x, and the other leg is 6 feet. X is the width of the rectangle. 2x is the length of the diagonal, which is the hypotenuse. By using the Pythagorean theorem, we have 2x, that quantity squared, which is the hypotenuse, equals x squared plus 6 squared, which are the two legs. That gives us 4x squared equals x squared plus 36. I am going to subtract x squared from both sides. That's going to give me 3x squared equals 36. I'm trying to isolate the squared term here. Now I'm going to divide both sides by 3, which gives me x squared equals 12. Now I'm going to take the square root of both sides. So x is equal to the square root of 12, which broken down can be the square root of 4 times the square root of 3, which is 2 square root of 3, which is approximately 3.46. So the width of the rectangle is 2 square root of 3 feet, or approximately 3.46 feet. And again, the negative solution to the quadratic equation is not considered because length is not negative.